The last session we discussed the refraction of the light. The term refraction means when the ray of a light changes from one medium, move from one medium to another, it changes its speed, and that is called a refraction. Same way, like example, the light which enter, that is the incident. When the light travel from air to glass, it slow down, so speed decreases. That's why it bend towards the normal, and then moving from glass to air, it further bend away from the normal, and the speed increases. What is the difference between the two figures? The first one, because the light was making certain angle with the normal, so when it travels from one region to another, it changes the speed as well as it changes the direction. But when it is passing along the normal, means it is passing straight, so in that case it won't change the direction, only thing what changes the speed. So moving from air to glass, speed decreases, and moving from glass to air, again the speed will increase. The next topic is critical angle and total internal reflection. What is the concept of total internal reflection? Example, there's a light which is passing through from glass to air. So what we observe, some of the light is refracted and some of the light is reflected. So this is a light which is incident. So the light which, this is an incident light. Imaginary line which is perpendicular to the surface, that is normal. So when the light is in the denser medium, because this is a glass, so glass is having a high density or denser medium, and outside there is air which is having a low density medium, or we can also say a rarer medium. So when the light is incident, the light strike the surface. As the light travel from glass to air, it bend away from the normal, and as it bend away from the normal, the speed of the light will increase. So the light which changes the speed, that light is known as refracted, and the light which bounce back, that is known as reflected. This is not total interreflection, but what happens if we increase this angle here, the incident angle, if we increase this, so what we'll observe, as the angle of incidence is increased, the angle of refraction will also increase. Like if this was 30 degrees, angle of say refraction might be 62 degrees, and angle of reflection was 30. But when we further increase the angle of incidence, now the angle of incidence may be increased to 40 degrees. So if angle of incidence is increased to 40, the angle of refraction, the angle between the normal and the refracted ray, will also increase. Example, that might change to 75. So some of the light will again refract and some of the light will reflect. And in case of reflection, the angle of incidence will always be equal to angle of reflection. So if what will happen if we further increase, like first it was 30, some of the light was refracted, then reflected. Now we made it 40, some of the light is refracted, some of the light is reflected. What will happen if we further increase this angle? So there will be a certain angle, this angle of incidence, there will be a certain angle when the light will refract or travel at a 90 degrees. So when the angle of refraction or angle of a refracted ray is 90 from the normal, so when this angle of refraction is 90, what we call this angle of incidence, this angle of incidence is known as critical angle. So critical angle means the angle of incidence for which the angle of refraction is 90. So basically what happened initially, like the three figures, how they're different from each other. We have a semicircular glass block. In a semicircular glass block, The light is passing from glass to air. So glass is having high density and air is having a low density. Glass is having low density, so speed of the light will be greater. And remember, whenever a light is traveling from glass to air, it will bend away from the normal and its speed will increase. So this is the incident light. So light is incident. An example, this angle was 30. What we'll observe some of the light is refracted. It can have any value for angle of refraction. Example, I'm taking that value as 62. So if angle of refraction is 62 and some of the light is reflected, so what will be the angle of reflection? Because in reflection, the angle of incidence and angle of reflection will always be same. So if angle of incidence is 30, the angle of reflection will also be 30. If we increase this angle of the incidence, originally the angle of incidence is 30. Like in this example, the angle of incidence is 30. But what will happen if we change the angle of incidence to 40? Now in this figure, the angle of incidence is changed to 40. What we'll observe some of the light will refract and some of the light will reflect. And because the angle of incidence is greater compared to the first value, the angle of refraction will also increase. Like if here the angle of refraction was 62, but now the angle of refraction will be, example, 75. And angle of reflection will always be same as angle of incidence, so this will be 40. So some of the light is refracted, some of the light is reflected. If we further increase the angle, example, now we change the angle of incidence to 42 degrees. So now this angle we further increase. So if we increase the angle of incidence, what we observe? We observe that the refracted ray is traveling at an angle of 90. This refracted ray is traveling at an angle of 90. So when this refracted ray is traveling at an angle of 90, what we call this angle of incidence, this angle of incidence which is 42 here, is also known as the critical angle. So the definition of a critical angle is it's the angle of the incidence for which the angle of refraction is 90 degree, and still some of the light will reflect. And what will be the angle of reflection? The angle of reflection will be 42, because angle of incidence will always be equal to angle of reflection. Is it clear, the definition of critical angle, the concept of critical angle? Is it clear till this point? The critical angle. So critical angle basically refers to the angle of incidence for which angle of refraction is 90 degrees. So example, when the light is moving in a denser light is moving from high density medium to low density medium, what are the things we observe? We will observe the light will bend away from the normal. This is what we observe. The speed will change, but the observation is that the light will bend away from the normal. So example, So this is a surface, light is there inside water, and it is traveling in air. It travels from water to air. So as this light is traveling from water to air, the light is moving in water. In water, the light is moving slower, but when it travels in air, it will move faster. This is imaginary line. This imaginary line is known as the normal. So when the light will travel from water to air or moving from water to air, what we'll observe? We'll observe the light will bend away from the normal. So this is angle of incidence, the angle between the normal and the incident, angle of incidence, and the angle between the normal and the refracted is angle of refraction. But if we increase the angle of incidence, like, and to extend the angle of incidence, what we'll observe? We'll observe the angle of refraction will also increase. So this is imaginary line which is perpendicular to the surface. That imaginary line is known as normal. And then when the light is traveling from water to air, again it will bend away from the normal. As the angle of incidence is increased, the angle of refraction will also increase. So angle between the normal and incidence is angle of incidence, and angle between the normal and the refracted is known as angle of refraction. If we further increase the angle of incidence, if we further increase this angle of incidence, what we'll observe? We'll observe the angle of refraction is 90 degrees, or light will travel along the boundary where the angle of refraction is 90 degrees. So when we label this is the angle of incidence and this one is angle of refraction. So now this angle of incidence for which angle of refraction is 90. What we call this angle of incidence? We call this angle of incidence is as a critical angle. So critical angle is basically an angle of incidence for which angle of refraction is 90 degrees. Is it clear? So when we are increasing the angle of incidence, the angle of refraction is increasing. So there is a certain angle at which the angle of refraction is 90. We call that as critical angle. And what happens when the light is moving from high density to low density medium? Some of the light is refracted and some of the light is reflected. So whenever light travels from water to air, some very small part of the light is refracted, a very small part of a light is reflected, and most part of the light is refracted. Now what is the concept of the total internal reflection? Example, we have a material, 4 different cases are there. And the light is striking the surface. Now what happens when we draw the imaginary line which is perpendicular to the surface? That imaginary line is known as the normal. Normal should always be perpendicular or 90 degree to the surface. So the blue line here is representing the normal. So what we observe, so this angle is 30 degrees, this angle is 40 degrees. This one is example 42, and we increase more than 42, example it is 43. Now when the light is moving from high density medium, this is a high density medium, and at the top we have low density medium. So when the light is moving from high density medium to low density medium, the light will bend away from the normal. So this will be the path the light will take. If we increase the angle of incidence, the angle of refraction will also increase. If we further increase the angle of incidence, the angle of refraction will be 90. So the first example, the angle of incidence for the first example is 30. For the second example, angle of incidence is 40, and for third example, angle of incidence is 42. Light is moving from high density to low density. What is the critical angle here? What is the value of the critical angle? Critical angle is same as angle of incidence when angle of refraction is 90. So for which figure the angle of refraction is 90? The first figure, the angle of refraction is not 90, it is less than 90. For the second figure, the angle of incidence, again, it is not 90. But the third one, the angle of refraction is not 90 in the second. The third one, angle of refraction, again, it is not 90. So this value of angle of incidence, here the angle of incidence is 42. So what is the critical angle? The critical angle is 42. So in this example, the critical angle is 42 because the angle of refraction is 90. So if we further increase the angle, like example, critical angle is 42. But if we further increase the angle, what we observe? Why not 43? Because when it depends from material to material. But when it is 43, what we observe? We observe all of the light is reflected back. There is no refraction. So when there is no refraction and all of the light is reflected back, what we call that? We call that as a total internal reflection. Why the critical angle is 42, not 43? Because when you see the figure, the angle of refraction is 90. So here the angle of refraction is 90. When the angle of refraction is 90, that value of angle of incidence is known as critical angle. So if the angle of the incidence is more than the critical angle, as you can see, the critical angle is 42 for this material. If the angle of incidence is more than 42, like it is 43, so what we'll observe? We'll observe total internal reflection. It means there will be no refraction. All of the light bounce back, and we call that as total internal reflection. In the first figure, some of the light is refracted, some of the light is reflected. In the second figure, some of the light is refracted, some of the light is reflected. Third figure as well. But in the fourth figure, what happened? There is no refraction, like light is not able to come out. It only bounce back in the same dense medium. We call this phenomena as total internal reflection. So if the angle of an incidence is more than the critical angle, then both will happen, reflection and refraction both will happen. But if the angle of incidence is greater than the critical angle, then in that case there will be only reflection, there will be no refraction, and we call this phenomena as total internal reflection. And this is only, we can only observe this when the light is moving from high density medium to low density medium. So if the angle of incidence is less than or equal to critical angle, then what we'll observe? We'll observe some of the light will refract and reflect. But if the angle of incidence is more than the critical angle, there will be no refraction and all the light will reflect. This is known as total internal reflection. So total internal reflection happen when the angle of incidence is more than critical angle. And critical angle, most of the question when you will solve, you will find the critical angle is 42, but it is not fixed 42. It can vary, but most of the material which they provide, they have the critical angle of 42, but it vary from material to material. So example, we have 4 different cases, and the critical angle is given. Example, the critical angle is 42. Critical angle 42 means, like, if when the angle is 42, the angle of refraction will be 90. Like the angle of incidence, when the angle of incidence is 42, the angle of refraction will be 90. That's why we call that as critical angle. These are the normal we draw. The light is traveling and at different angles. Example, the first one angle is 20, the second one angle is 30, the third one angle is 42, the fourth one the angle is say 50. Now when we check, as we know, the material, the critical angle is 42. Critical angle 42 means, that means when the angle of incidence is 42, the angle of refraction will be 90. But if the angle of incidence is less than the critical angle, then what we observe, some of the light will refract, because sometimes they ask to complete the path of the ray. So how you'll complete the path of this ray? Some of the light will refract and some of the light will reflect. Same here, some of the light will refract, some of the light will reflect. Here, when the angle of incidence is 42, because 42 is a critical angle, what is the meaning of critical angle? Critical angle means the angle of refraction should be 90, like light should travel along the surface, so the angle of incidence is known as the critical angle. And even if it is critical angle, some of the light will refract and some of the light will reflect. But if we further increase, like we made it 50, now this angle is more than the critical angle. So what we'll observe? We'll observe total internal reflection. So in the first one, is there a reflection? When we check a refraction and reflection, the first case, so refraction yes, and reflection also yes, because the angle of incidence is less than critical. The second case, there was a refraction. Yes. There was a reflection. Yes. The third one also, even it's a critical angle, there is a refraction and there is also a reflection. But the last one, the refraction, there is no refraction, but about the reflection, yes, there is a reflection. So there is no refraction, only reflection occurred. That's why we call that as total internal reflection. Is it clear, the concept of total internal reflection? How refraction in the last diagram, as you can see here, the term refraction means the light should change the speed. So first it was moving in a glass and this part is in air. So when the light changes the medium, when the light travels from one material to another, it's called refraction. Here, this is glass, air, so refraction. This is moving also from glass to air. This is also refraction. And this is also reflection because it bounces back in the same medium. So when the light changes the medium, we call refraction. But if the light does not change the medium, it just bounces back, that is reflection. That's why in the last one, the last figure, the light does not go out in air, it bounces back in the same medium. So we don't say there's a refraction, we say it is only reflection. Even the light is traveling at a 90-degree, but it come out from the glass and it move along the surface, it changes the medium. That's why it is refers to refraction. So this angle for which the angle of the incidence, for which the angle of refraction is 90 here, and the light move along the surface, because the light changes the medium, so there's a refraction. So we call this angle of incidence as critical angle. And if we increase the angle more than the critical angle, then what we'll observe? We'll observe a total internal reflection. That angle of incidence is greater than critical angle. All of the light will reflect back in the same medium. There is no refraction. So this is refers to total internal reflection. Is it clear? The concept of total internal reflection and critical angle. Then the formula which relate critical angle and refractive index. So relating the critical angle with refractive index. Basically what happen in a critical angle, the light is in the glass or water, or like it's in a dense medium, and it travel along the surface. Some of the light is refracted, some of the light is reflected. The reflected part we are not considering because we want to just complete the figure. So example, whenever there is a critical angle, the angle of refraction is 90 degrees. This is the angle of incidence. So whenever a light is moving from glass to air, like light is there in glass and it is moving in air. So traveling or moving from glass to air or high density medium to low density medium, the formula for refractive index, The formula which we use for refractive index is sine r over sine I. This is the formula which we use when the light is traveling from glass or water to air. So sine r, what is sine r here? Angle of refraction is 90. And what is angle of incidence? That is a critical angle. So when we substitute these values, so we can say n is equals to sine 90 divided by sine I, but because it's a critical angle, so we can say small c. What is sine 90? When you apply the rule, trigonometric ratio, sine 90 is equals to 1. On your calculator, you can find. So sine 90 is 1. So we can say that refractive index is equals to 1 divided by sine C. So the formula which relate the critical angle and the refractive index, that is n is equals to 1 over sine C, where n is a refractive index, that's the ability of the medium to bend the light, where C is the critical angle. Is it clear? The formula, so this is very important formula. You have to learn that sometimes they give you the refractive index and they ask for critical angle, and sometimes they give you the critical angle, they ask for refractive index. So here you can see what is the concept of total internal reflection. The light is entering, this is a beam of the light which is passing through a semicircular glass. Here, because it is passing along the normal, because normal is always perpendicular to surface. When the black line is representing a normal here. So when we draw the normal, this is a normal, because normal is always 90 degree to the surface. So if this is a surface, when we draw the normal, it should be 90 degrees. So when we draw the normal, the light is actually passing along the normal. Whenever a light is passing along the normal, it will pass straight. So when the light will pass straight, then what happened? Again, if we draw the normal, this is a surface. So we draw the normal, which is perpendicular to the surface. So the angle between the incident and the normal, the angle between the incident and the normal is known as angle of incidence. So when a light is moving from glass to air, what we'll observe it will bend away from the normal. Some of the light is refracted and some of the light is reflected. This is a case when the angle of incidence is less than critical angle. But if angle of incidence is more than the critical angle, when the light is moving through a glass, because this angle of the incidence is greater or more than the critical angle, so what we'll observe a total internal reflection. So instead of light will go out and refract, what will happen to the light? Instead of going out and refract, it will reflect back in the same medium. So this is a phenomena of total internal reflection. Is it clear? The concept of total internal reflection. So as you can see, if the angle of incidence is smaller than the critical angle, some of the light, here the reflected one is not drawn, but still what happens, some of the light is reflected. If the angle of incidence is equal to the critical angle, the light will travel at 90. And if the angle of incidence is more than the critical angle, then we'll observe a total internal refraction. All of the light will reflect back in the same medium, refers to total internal reflection. Then what is optical fiber or fiber optic, or also known as light pipes? So optical fiber or fiber optic, this is the optical fiber or fiber optic. What happened? It's a transparent material, made up of transparent material. But what happened when the light is strike? Light is in a dense medium. This is a normal. So always what we observe, the angle of incidence, this is the angle of incidence, and all the point, the angle of incidence is more than the critical angle. So if angle of incidence is more than the critical angle, what will happen? The light will reflect back in the same medium. It will bounce back in the same medium. Then when it strikes the surface, the angle of the incidence here, again it is more than the critical angle. So what will happen? The light will bounce back in the same medium or reflect back in the same medium. Then further the angle of incidence is more than the critical angle. At this point, the light will bounce back in the same medium. So using this optical fiber or fiber optic, we can transfer the light from one place to another, or we can transfer the information in the form of light from one place to another. So that's the advantage of using these optical fiber, that there is no losses or very small amount of light is lost, and most of the light which enter from one end of optical fiber transfer to the other end. So light pipes or optical fiber, it's a transparent material, made up of transparent material, and it is used to transfer the light from one place to another. And the internet signal, the internet which we are using through optical fiber, is actually transferring the data or information in the form of light. So when the light is passing through, we want the transfer of all information or data from one place to another. So we don't want the light to escape. Otherwise, what happens? The light, when it is moving from denser to rarer medium, it might go out. But why it is not going out? Why this does not happen? Because every point the angle of incidence is more than the critical angle. So when the angle of incidence is more than the critical angle, the light will reflect. There's no refraction. The light will reflect back in the same medium, and it will undergo a total internal reflection. Is it clear? The concept of optical fiber and how it transfer information or light from, or it how it transfer light from one place to another. Any doubt till this point? So now we'll do some questions related to the critical angle and total reflection.